Good evening. Welcome back to our lesson, Clinton Math Academy. Feel relaxed, comfortable, and enjoy the lesson. Today, we're going to learn about probability, whereby we're going to say that probability is equal to favorable outcomes in an event over total possible outcomes in that event. The event that we're going to say here is an experiment that is going to be conducted when we say the issue concerning probability. Now, the range of probability falls from 0 to 1. So for any event to happen, it's going to be having an unlikelihood or likelihood of happening. Now, so the range of, when say unlikely events, these are the probability of for us having the lowest chances of something of appearing or happening. So, for example, being absent in school in examination day. So that one is an unlikely event to happen because it is good to know that most of the students are likely to attend that examination. Another one, scoring 100% in every examination. So it is not likely that you can score in each and every examination 100%. So it's that one you say unlikely. So falling between the range of 0 to half in this probability range. Now we also have what we call likely events. Now the likely events in probability, they have the highest chances of happening or occurring. And then they fall in the range of half to 1. That's what we call likely events. Example of a likely event that we may want to say that probability that a week is having 7 days is 1. Finding books in a school library, that's another chance that's likely to occur. Whereby we're going to find some all schools in maybe in a country that in a library we may have different types of books to be there. So you have highest chances of finding books in that particular library. Now, the probability of an event A happening is equal to 1, and the probability of an event not happening is equal to 0. If the probability of an event not happening is equal to 0, that means it is impossible event. Now, the probability ranges between 0 to 1, that we have said. Now, probability of an event happening plus probability of an event not happening is equal to 1. Now, we may say, for example, we take a coin and then we toss it. So the probability that we're going to get a tail or a head is going to be half, and the probability that we cannot have two of them appearing at the same time is equal to 0. So the probability of, we can say half, you can say 1 is going to appear, and then so that range, probability of something happening plus probability of something not happening, which is 0, is equal to 1. So if probability of something happening is 1, and the probability of something not happening at the same time is equal to what? 1, because probability of something happening 1 plus 0, you get 1. Probability of something not happening is equal to 1 minus the probability of a chance of something happening. Now let's go to mutually exclusive events. We say that two or more events are mutually exclusive if they cannot occur at the same time. Now, for example, a team winning in an event. Let us check that example. It is either if team A is playing against team B, it's either team A to win at that particular time, but not win and lose. So the probability of winning excludes the probability of losing at that particular time. Now we say, if we have chances of something happening, probability of A happening, and the probability of B happen, if they happen at the same time, both of them is equal to 0. That means that we say, if probability of something happening A and its probability of something not happening, B, let's say 1 times 0 is equals to what? 0. Now, that means that it's either A happens or B. Now, for example, we are going to say that probability of A plus probability of B. That is according to the law of probability in addition. So we may have probability of A plus probability of B. So that's why we have this OR in that mutually exclusive event. For example, a bag contains 2 green marbles, 7 yellow marbles, 11 magenta marbles. A marble is picked at random from the bag. Determine the probability that it is yellow, or green. It is green or magenta. Now, just relax. Let's have a bag of ours at this particular point. Imagine the bag is containing 2 green, 7 yellow, and 11 magenta marbles. So what is the total number of marbles in that particular bag? We're going to have 2 plus 7 plus 11. So total number of marbles is going to be what? 20. Which means the sample space or the probability space is going to be 20. Now, what is the probability of picking a green at that particular moment? So we are going to say that we're going to have 2 over 20. Now, 2 over 20. What is the probability of picking 7 yellow marbles? We can have 7 yellow marbles, of which we're going to say the probability of picking 7 over 20. A probability of picking 1 marble from that bag is going to be 11 over 20. Now, let's go and see what is the probability it is yellow. The probability of picking a yellow is going to be that chance of 7 over the total sample space, which is what? 27 over 20. What is the probability that you pick, whatever you're going to pick is green? So how many greens were there? There were 2. Now, 2 over 20, which is what going to be 1 over 10. Now, there's an error here. It should be 2 over 20 to give you 1 over 10. Now, what is the probability that you are going to pick yellow or green? So it means that for you to pick yellow or green is going to be the probability of yellow plus probability of picking green. Probability of picking yellow is 7 over 20 plus the probability of picking green is equals to 2 over 20, which gives you 9 over 20. So these are mutually exclusive events. So they can also, because we are seeing OR here, yellow, and we have also green. Now let's go to probability that it is green or magenta. Probability of green or magenta is going to be the probability of picking green 2 over 20 plus probability of having that chance of picking 1 magenta 11 over 20. Whenever you add, you get what? 13 over 20. So that one is going to tell us that 2 or more events are mutually exclusive if they cannot occur at the same time. Now, another example of a mutually exclusive event is that getting ahead or tail in tossing a coin. So it said that you're going to get head that is going to exclude a tail, or you get a tail that's going to exclude what? A head. Independent events. Two or more events are said to be independent if the occurrence of one does not affect the occurrence of the other. That means 2 events cannot occur at the same time. For example, you are in a plane. The probability of you being a male, being served coffee, tea, or juice, does it mean that the probability, because you are a male, you're going to be served coffee, or you are a woman, you're going to be served tea? Now, the two events are separate. We say that now those 2 events are subservient to one another, meaning that they are going to occur separately in that particular regard. Now, for example, we can say tossing or rolling a die and tossing a coin at the same time. Now, whenever we toss a coin or a die, it's either you're going to get the probability of tossing a coin, we get R for the tail, and the probability of tossing a die for 5 to show up is going to be what? 1 over 6. So 1 over 6 times half, and then we get what? Those two events happen, those events occur. The event now we mean that two or more events are to be independent if the occurrence of one does not affect the other. So they're going to occur there separately. They're going to happen separately. So that means that probability of A and B happening according to the laws of probability, and means probability of A times probability of B. The mathematics says that you have to multiply probability of A times probability of B. An example, the probability that David walks to work is 3 over 5, and the probability that he buys a fruit on his way to work is 2 over 3. Find the probability that he walks to work and buys a fruit. Now, in this particular question, we're going to have two events happening differently. The first one, probability of walking and the probability of what? Buying a fruit. So you can say probability of walking to work and the probability of buying that fruit. So the probability of walking to work is 3 over 5 times 2 over 5 of that of buying a fruit to get to 2 over 5. Those two events happens differently. Dependent events. Now, we say two or more events are dependent if the occurrence of one event affects the occurrence of another event, i.e., picking marbles from a basket of different colors without replacement. Yeah. And then a basket, for example, contains 5 pink marbles, 4 orange marbles. 2 marbles are picked from the basket at random, color noted, and placed aside. Find the probability that 2 marbles picked are as now let's go and answer that question. Different colors, all are pink of the same color. Now, in this particular case, we are dealing with dependent events. Now, dependent events is that when two or more events are dependent, they cannot the occurrence of one event affect the occurrence of another one. For example, take a bag of 2 oranges and 2 mangoes. So if I want to take 1 mango, then all of them, the sample space was 4. If I take 1 mango and then I remain with 2 over 3. So there's the first chance has happened to occur in the next event without what? Replacement. Now let's see this question. Now, a basket contains 5 marbles which are pink, 4 orange marbles. Yeah. So what is the sample space of 5 and 4? So the sample space of 5 and 4, 5 and 4, we're going to say 5 plus 4. The sample space in that particular event is what? 9. Now that means, what is the probability now? In the first case, first picking, and then one is going to be what? Second picking. Without what? Replacement. Let us have the first picking. So if we pick for 5, probability of picking a marble which is pink is going to be 5 over 9 because of the sample space, which is what? 9. What if we pick, this is the first picking, and what if we pick for the orange marble 4 over 9? First picking. What are the second picking? Because the question said 2 marbles are picked from the basket at random, colors noted down without what? Replacement. Second picking, whenever you're going to pick the second pink marble, they're going to be 5 minus 1, 4 over 8 here. Now, whenever you add this fraction that are going to be here, they must give you 1. So 1 minus 4 over 8, so that they will get 4 over 8 in that particular side. Now, let's go down. The probability of me picking the second orange marble from the first one is going to be 4 minus 1 is because of the second to remain 3, or over the sample space now is going to be 3 over 8. But now you must know that whenever you're going to add this fraction, this particular branch, you must get what? 1. Now, that's, and then you must know you note down the colors picked, pink, 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 orange, in this particular direction, orange, pink, orange, orange. Now, let's answer question. Colors picked different colors, the first case. So, of different colors, we get pink, orange, we got orange, pink. So let's start with the first case. We start from here to go to this side. Pink, orange. So it means that 5 over 9 times 4 over 8, 5 over 9 times 4 over 8, plus or, and then 4 over 9 times 5 over 8. Whenever you add, you get what? 5 over 9. Because or means we're going to have two 8 occurrences of two events, pink, orange, and orange, pink. Same color, pink, pink. So it's going to be, for us to have that one, we're going to have 5 over 9 times 4 over for 5 over 9 times 4 over 8, so that we get pink, pink. And then, or we get orange, orange, 4 over 9 times 3 over 8, 4 over 9 times 3 over 8. Whenever you add, it means 4 over 9. Or are pink. Pink is this one, this side, 5 over 9 times 4 over 8. So we have 5 over 9 times 4 over 8. You get 5 over 18. Thank you for watching. Subscribe for more mathematics lessons.